Good afternoon, my fabulous chemistry students. Video 12% error today. This will be the last video of Unit 1. Please understand that there is error associated with every measurement that we take, and we will be able to calculate percent error when we are done with this video. So what is percent error anyways? Well, first we need to realize that every time we take a measurement, and we do take many of them, there is a slight error involved. This error might lead to me, say, getting 49 grams of product. Well, if my balanced chemical equation says I'm going to get 50 grams of product and I get 49, there is an error. I can calculate that percentage by manipulating those two values. So on to the notes. Measurement of percent error that the measured value is off from the accepted value. This measured value is the value you get. The accepted value is the value you should get. So let me put that in other terms for you. Our measured value is our experimental value, where our accepted value is our known value. Let me give you an example real quick. Copper. We're going to calculate the density of copper, and I look it up. The density of copper should be 4.1. But what if we get 3.9 in lab after we mass it and its volume and we do our calculations? See, there you go. We have an error. We can calculate now, because we have an experimental number and our known number, what the percent error is. And that is found right in Table T. When we get our reference tables, it will be written for you. You will never need to memorize it. Here it is. Excuse me, percent error. Measured value minus the accepted value, all divided by the accepted value, times 100 because it's percent. If our value is negative, well, then our measured value is less than the accepted value. If our measure is positive, then it is more than. That means this number has got to be there and this number has got to be there. It's always got to be this way. We don't just subtract the high number from the low number. It's always got to be experimental value minus the accepted value. That's going to lead to this whole negative and positive and help make sense. Were we high? Were we low? So here is an example problem. In a lab experiment, you were told that Coke should have 39 grams of sugar. We figured out that there was 40 grams of sugar. So we need to plug this into our equation. Again, plug and chug. Let's plug it in. It's going to be experimental minus their known. I'm just using different words in case this helps you. So that's going to be it, times 100. That's basically our equation from the previous page. So here's our experimental. Let's plug that in. 39 grams minus 40 grams divided by 40 grams. All times 100. Now we just need that handy dandy calculator, and we can chug it out. So I get 39 minus 40 equals -1 divided by 40 equals -0.025 times 100 equals minus 2.5% error. Okay? Our number that we got was smaller than our accepted value by 2.5%. That's what that means. Now, we just went through percent error. It really is that fast and simple. There's practice for you to get good at honing the skill to make sure you're plugging and chugging the proper way. You can now calculate percent error. This is the last of our notes. It was under 5 minutes. Hallelujah, Mr. Milks. Thanks for coming. Everybody study good for your first unit test. See ya.